Welcome to the Punny Math Teacher. Some expectations from the beginning are to use twice this video's length to take notes and ask questions and wonder about the world and all patterns that you're seeing. Remember, these are notes to your future self, so make sure they are legible and you actually understand what you're using. If you're going to say a shorthand, make sure you know what that represents later when you come back and watch this or read this. Pause, rewatch, change the playback speed. That's all yours to change and do as you need to, and then use my website for more resources. Today, our objective is to simplify expressions, and we're going to use a specific order, but it is more flexible than some people would have you think. So order of operations is going to be on page 4. Make sure it's headed up. All right, so the order that I'm going to be using is called GEM-DOS. I like to say, I like to group the M and the D together, the A and the S together. You'll see why. So we only need 4 rows and, 4 rows, but then I am going to do a final example at the end that's a little different, but uses some of the properties and things you're going to see in the future. So our first one is going to be G, and this stands for grouping symbols. Then we're going to have 2 examples under here so you can see how that works. Then we're going to go into exponents. This will have 2 examples as well. Then we're going to have M and D, which we do at the same time, moving from left to right. So this is a multiplying and dividing. We're going to have 1 example specifically with this one. And then A and S, which is addition and subtraction. We're going to have example 1, example 2, and then I want a final thought, a final example that we're going to go over. All right, so grouping symbols. So grouping symbols are divided by fraction bars, brackets, and parentheses. It could be fancy braces as well. So our example 1 will be 5 plus 4 is all divided by 18. So that 5 plus 4 is one group and the 18 is one group. I need both of them to be fully simplified before I actually do the division. So this is an example of having a fraction bar that creates 2 groups, and I need to simplify the numerator and denominator before dividing. So think of that fraction bar as division. I have to get those 2 groups simplified before I can do that division. So 5 plus 4 makes 9. Now when I simplify, I get 1/2. But I had to do the 5 plus 4 first. For example 2, we're going to have 3 times 6 plus 2. So this is one strategy. We're going to come back to this one actually. This example, I have a different question for it for the final. But we're going to come back to this idea. This is a group. So 6 plus 2 is all grouped together in parentheses. So I'm going to do that addition first. So it's 3 multiplied by 8. And this is going to equal 24. All right. So I'm going to simplify in the parentheses first. All right, moving on to exponents. So exponents, they mean the number of times you multiply the base. So if I have 2 cubed, in order to simplify this, that means 2 multiplied by 2 multiplied by 2. 2 times 2 is 4 times 2 is 8. So this is going to multiply out to make 8. And using that in more of an expression, we can see 3 multiplied by 2 plus 4 all squared. So I'm going to do the group inside first, that 2 plus 4. So I'm going to have 3 multiplied by 6. But that 6 is still being squared because that parenthesis group is still being squared. And then 6 squared is going to be 36. So notice I did the squaring first because now we're going to come to multiplication and division step and multiply that by 3. 3 times 30 is 90. 3 times 6 is 18, so this is 108. That's your final answer. So this last step is actually the multiplication division step. So we first did grouping symbol, then we did the exponent, and now I'm going to do the multiplication. So each step was something different, and now we're on our multiplication and division. Remember that we go left to right. So example 1, I'm going to have 3 multiplied by 4 divided by 2, 1 plus 2. So I could have written this as a fraction, 3 times 4 over 2 times 1 plus 2, but instead there's a division in the middle. So I'm going to go from left to right. I am going to do this group first though, just so it looks a little more straightforward as my computer's overheating. All right, and then 3 times 4 is 12. Now I've divided by 2 times 3. Aha, and this is where the fraction wouldn't have actually worked because I'm going from left to right. So 12 divided by 2 is 6 divided by 3, and that gives me 18. So think about it. If I had actually made these as 2 different groups, would my answer have been the same? Addition and subtraction. Again, we're going left to right, and remember that a minus is the same as a negative. All right, so example 1, we're going to have 3 plus 4 minus 6 plus negative 12. I'm going to write this one out too as I worry about my computer. Oh boy. Okay, so left to right, left to right, left to right. 3 plus 4 is 7. And you can drop the parentheses if you want. Sometimes we put the negative up higher instead of making it look like a subtraction sign. 7 minus 6 is 1, but you could also write it just as a subtraction sign. This is the exact same thing. It's 1 minus 12, so I get negative 11. Try example 2 on your own. Remember, subtracting a negative is the same as adding a positive, so this is actually 9 plus 7, which would be 16. And then for my final thoughts, I want to go over 2 times 3 plus 4 minus 5. So noticing up here, we did the group inside first. Here we did the group inside first because this exponent was more than a 1. When the exponent is just 1, we can do a different trick, which you're going to learn later. So I could simplify this 2 different ways. I could do the group inside. 14 minus 5, which will be 9. Okay. Another way is to do the distributive property, which you will learn soon. Okay. So that means I'm going to multiply or distribute that 2 into my group. So 2 gets distributed to the 3 and to the 4. Then when I do this multiplication, I subtract the 5 from the end of everything. So that's 14 minus 5 equals 9. So it doesn't matter the order. I didn't have to do the group in first. I could multiply because this is parentheses. This means multiplication. I could do the multiplication first, and that's okay. So sometimes the order won't be the exact same as what we've had. Just making sure that you're still doing multiplication, and then I did my addition last. So making sure the order is a general guideline, but there are different ways that you can do different things to isolate variables or simplify expressions, etc. So just know that we have some loopholes and exceptions, but we're still following the general order. All right, and I'm going to minimize this. Comprehension questions for today. Why go left to right? Can you make an expression where the answer would be different depending on the order? And then a why is a numerator a group, or why is a denominator a group? So think about those, discuss with a partner or someone near you, and have a great day. Thanks for watching.